Hey, hi guys. Thank you so much for tuning into my channel and helping my community cross 1,000 members. It's been about 2.5 to 3 weeks that this channel has started, and it really means a lot for the support that has been shown to my channel. Now, today's topic is something very close to me, and it's a follow-up on my earlier video on DeepSeek versus ChatGPT and what the evolution of DeepSeek means. Now, this video is an attempt to explain how AI works in a very simple manner. Okay, now look at AI in a very similar way. It's like a neural network. Okay, that's very similar to how our human brains are. So, human brain, if you look at it closely, it's basically a very complex network of nerves. Now, in case of AI also, it's basically a replica of the human brain. So, it tries to replicate the same way in the form of nodes. Okay, so every time there is an input layer, then there are multiple hidden layers, and then there is an output layer. So it's the same kind of complex nerve system that is there in our human brain. So when anyone builds an AI platform, it tries to replicate the same phenomena. So any input that comes in, there's an output that happens, and during each of these layers, there is a certain information parameter that gets passed, like a certain percentage of. Now, one major difference is that when we talk about the human brain and the neural networks, like each of these nodes has either got an all or nothing mode. So when certain information passes on, when we, let's say, we watch a tree, like when we are watching, so how a human brain processes it, we each of the nodes, whichever is getting that information, it decides to either pass the information to the next node or not pass at all. So it's either a 0 or a 100. Okay, and finally we come to the conclusion that it's a tree because we can recognize that image that it is that of a tree. Okay, now in case of the neural network, in case of AI, so there is a percentage mode as well. Like you can decide what percentage of the information is to filter in. And in a similar way, like when we are training the AI, when we are building that AI model, for it to recognize, there is a lot of training effort involved and a lot of data also which goes into it. Like the data has to be filled in, it has to be looked at, like either it has to be supervised learning, where in case the AI model is not able to identify it correctly, the accuracy percentage is lower, then it gets a penalty where the supervisor essentially then refeeds the entire model. So this large language processing models, so it's again re-entered and it's taught again that no, they have identified it wrongly. So if you look at it in an analogy way, it's similar to a human child. Now, as the AI is trained more, it essentially evolves like an adult. Its intelligence level increases, its capacity to think increases. It kinds of builds a subconscious mind if we recollect it correctly. So it is able to build context to the prompts that we give. Now, in AI terms, when we are providing any form of prompt, it's considered as a token. So what exactly is a token is, like it's a combination of certain words. Like for example, if you ask that how cold is New Delhi? Okay, so how it will treat is, like it will treat the word how as a combination of numbers, and that's considered one token. So how will be one token, cold will be one token, is will be one more token, new will be another token, then Delhi will be another token and followed by the exclamation mark. That's considered as another token. So in total, there is about 6 tokens in this. So whenever we are prompting it, whenever we are giving this kind of prompt, now the AI model has already been trained with a lot of data points. So it tries to figure out, it tries to build up a context to that, and based on that context, it then generates a response. So this happens through a reiterative process. So in case the AI model, when it is getting trained, it has not been able to get 100% accuracy at one go, or a far lower than acceptable accuracy part, then the same information is fed again that no, I've identified it wrongly. Very similar patterns. Like for example, if the AI model has to identify an image, let's say it has to identify a ship. Okay, so how the AI model is trained is, it is fed certain keywords that this is the kind of ship and the image. So it tries to build up that analysis. So whenever next time a ship image comes up, It sends those information across the neural network through the various nodes, and based on the parameter, it adjusts the nodes. It's taking up the it defines it that what would be the output response of it. So as long as it's shipped, then the training has been proper and it is able to identify it. Similarly, it can fail at certain instance also when it may not always give a correct response. Now, there has been a lot of these things that about DeepSeek that has been now coming up in social media is that for certain prompts, it's saying that it is out of scope. Okay, or this DeepSeek is not trained to answer these kind of questions, or a very similar prompt to that, and especially for geopolitical purposes. Now, this does not demean the model as such, okay, because the model is essentially working on how it is trained out. Okay, now for example, if it fails to identify it correctly, okay, so in that case what happens is there is a process known as backward propagation. So during backward propagation, what happens is you provide us the output. So if the output is that of a ship, like for the previous example that I showed, so it then reverts it back as to how the nodes should be configured to get the same output, and then it takes the same configuration forward. Now this is how essentially the various AI models are trained as well. Like this knowledge can be passed on from one AI model to another using a process called distillation, which I will discuss in my later episodes as well. So right now my basic purpose of this episodes is to just help you understand as to how AI networks work, and just to provide a brief of it, that how it's similar to a human brain, and it's about how we are training it. That's what makes it the difference. So the training makes a huge lot of difference, and then each of the prompts that we give, they're considered as tokens. So based on the number of tokens, the pricing of these AI models vary. Like for example, in case of OpenAI, the pricing is roughly about $4.4 for a million tokens when it charges for any commercial use. Okay, whereas in case of DeepSeek, it's roughly about 10 cents. So that's essentially the very difference. Like the pricing becomes a very significant part, and because its pricing is so low, and it is able to build a very similar model with lower GPU powers. Basically, the NVIDIA chipsets that it is using is of a lower variant than that what is used in case of OpenAI. So it's consuming much less power as well. So it paves the way for others also to explore the similar route, whereby lower power GPUs can be used for building very similar AI architecture platforms at a lower cost, and that brings down the cost significantly. It helps others to adopt it and also build similar platforms. So that's the essence of point of it. I am presently going through the research paper that has been published by DeepSeek, and I will come up with very detailed video in my later episodes as well on the same topic, on same areas, as to how DeepSeek has been able to build this platform at such a lower cost in my view. So look forward to seeing you all guys, and hope you like this episode, and do like, share and subscribe. That would mean a lot for my channel, and thanks a lot again once again for helping me reach 1,000 subscribers in a very short while. See you soon. Thank you.